Hi everyone, welcome to our video on overview of language models. In this section, we'll be exploring a fascinating aspect of artificial intelligence, which is language model. So language models are a type of AI technology which is crucial in understanding, interpreting, and generating and responding to human language. So these models form the core of modern natural language processing applications, which we actually interact with daily in various forms. So one key question we would like to address in natural language processing commonly is how best to represent the meaning or semantics or the structure or syntax of human language in these models. This involves complex processes and innovative methodology to do this effectively. So let's take a look at this case study. We'll look at the word bank. According to WordNet, which you're looking at on the right side, WordNet is a lexical database for English language, and let's explore the different senses of the word bank, and how language model will be able to actually distinguishes between different meanings of the word bank in various contexts. You can see that based on the grammatical form, so whether it's a noun or a verb, and the context of word usage, the word bank can represent numerous different senses. This highlights the complexity and the sophistication that is required in language models to accurately interpret the nuance of human language. So now let's delve deeper. Then what are the necessary components that should be modeled to accurately identify the semantic of the words like bank? It's not just about the word itself, but it might be about the position of the sentence, the word before and after it's coming, and even the sentences that precede and follow. So all these elements can collectively contribute to our understanding of the word and its meaning and the syntax and the semantics in a given context. So how do we actually model these components effectively and efficiently in a language model? Because it seems like a very difficult task even for humans. It's a challenge that involves both linguistic insight and advanced computation technique. So let's take a look at the components more in detail. First, the position. So the location of a word where the word bank is located in a sentence can drastically alter its meaning because it might influence the grammatical form or grammatical function the word is holding. And next, the word before and after. The surrounding words provide a crucial context, a lot of times aiding us to disambiguate the meaning. Then sometimes the broader context of adjacent sentences or the preceding or upcoming sentences is necessary to understand and to fully grasp the understanding of the meaning of the text. Then how do we do this actually effectively and efficiently? In order to tackle this task effectively, there's been numerous different algorithms that has been introduced, and we'll mainly focus on the two, which is called recurrent neural networks, in short RNN, and long short-term memory network, which is called or LSTM. So recurrent neural network and long short-term memory network has been widely adopted to tackle this task effectively. So both RNN and LSTMs are designed to train this language model, which process human language for various different tasks. And this task could involve various different types of things, such as text classification, prediction of the text quality, summarization of the text, and even topic modeling. And their ability to understand and generate human language has made them fundamental in the development of the advancement of many of the NLP tasks. Then what makes this RNN and LSTM model powerful enough to be able to capture such intricate understanding or distinction between the meaning? Let's try to understand the core strength of RNN and LSTM. So RNNs are capable of maintaining a form of memory of previous input, and which allows them to consider the context when predicting or classifying or generating new following continuation of the text. And LSTM, which is an advancement type of RNN or recurrent neural network, are designed to remember more of a longer-term dependency, making them particularly effective in understanding context over longer sequence. So let's consider the sentences. He sat on the bank of the river, and the pilot had to bank the airport. Let's assume that the word river in the airplane, which is a continuation of the previous words, are not available at this moment. So in the first sentence, the bank refers to the side of a river, while in the second, it's a verb meaning to tilt. So LSTM and LSTM models, or the RNNs, can discern these differences between the word bank in the first sentence and the verb form of the word bank in the second sentence by looking at the surrounding words. So in case of the generating language or language generation problem, these models can predict the next most likely word in a sequence. For example, after he sat on the bank of the model, RNN or LSTM, will recognize the context of the previous words, such as the bank or said, or and then we'll be able to predict a word, river, or a similar word as this as a probable continuation of the sentence. Similarly, the pilot had to bank, the model understand the word bank as its work is used in a verb form, hence we'll be able to continue the word as something that is associated with the pilot's action. So something like an airplane would be a great continuation of the sentence. Then how are these RNN and LSTM model will be able to do such powerful thing? In order to understand that, we'll take a look at how the RNN and LSTM function more in detail by taking a look into their architecture. So word order is a crucial part of or crucial aspect of language understanding, and in RNN and LSTM, this is captured in a hidden state. And hidden states are a form of memory that holds information about the sequence of word that is processed so far, such as, processed so far. And as the network processes each word, the hidden state is updated, thus encoding the word order and then the contextual information that each of the word is deriving from. However, managing this hidden state is not without its challenges. So it could be a very difficult task. So one significant issue with managing this hidden state is vanishing gradient problem, especially in recurrent neural network. And vanishing gradient problem refers to where the network becomes less effective and learning dependency because between words, there are far apart in the sequences. And in order to address this problem or challenge, LSTMs were developed to mitigate this issue, but they still face challenges in capturing extremely long-range dependency. So the hidden state's role in contextual understanding is very profound. It allows the model to interpret each word in the context of the words that comes before it, which is essential for understanding the meaning of sentences, especially those with complex structure or ambiguous terms. So let's consider the earlier example. He sat on the bank of the river. And if you remember the other sentence that we had, the pilot had to bank the airplane. The hidden state helps the model to discern the word between the word bank and the other uses of the bank. And this understanding is pivotal if you were to understand the next upcoming word in a language generation or comprehension task. So to sum up, while the hidden state in recurrent neural network and LSTM, which is highlighted over here, can effectively capture word order and provide contextual understanding of the word and a sentence, it can come with a various different challenges. And addressing this issue is crucial for continued advancement in language modeling so that we can more accurately and effectively capture and interpret the meaning of human language. So in our next video, we'll explore how the introduction of the transformer model can overcome this issue of LSTM and RNN in terms of creating language models.